In this video, I will show you how to make an awesome scene transition using the Compositor Effects. For the tutorial, I will be using Godot 4.3 and I'm also using a GLSL file and a GDScript file as a starting point for the compositor. Links are in the description. I already have a video about them, so if you haven't watched it, click this button thingy here, otherwise this video might feel a bit hard to follow along. And now with all of that out of the way, let's get started. Alright, I have these two scenes. And in both of them, I have this scene switcher node. It has a script which allows me to switch between the two scenes. Then in this world environment node, you will have this compositor slot. Add a new compositor, you will have the compositor effects. Hit add element, you will have this new transition effect. This is only showing up because of the two files I mentioned earlier. Select it and nothing will happen. Don't worry, I will change that in a bit. And that's all for the initial setup. Now the first thing is, I want to pass a noise texture to my compute shader. So in the GLSL file, first I will create a sampler 2D uniform to catch the noise texture. Layout, binding equals 0, and setID equals 1. SetID needs to be different for every uniform. Then uniform, sampler 2D, noise texture. Then in the main function, let's just visualize the noise texture for now. So let's sample the texture. Float noise equals texture, and the texture to sample is noise texture with UV, and take the R channel. Now here I don't have the UVs, but I can calculate them easily. Vec2 UV equals pixel coordinate divided by screen size. Then here simply color.rgb equals vec3 of noise. In Godot, open up the template script file. I've renamed it to transition effect. And in the initialize compute shader method, you need to make sure that you have set up a correct path for your GLSL file. Alright, let me first create a texture 2D variable for my noise texture. Export var noise texture of type texture 2D, and with this export annotation, I can set the noise texture from the inspector. In the inspector, you will have this noise texture slot. Select new noise texture 2D, then uncheck this generate MIP maps. I don't need MIP maps. In the noise slot, select new fast noise light. Here you will have nice noise texture, and you're more than welcome to experiment here. In the noise type, I will select Perlin, then set the frequency to 0.02. In the fractal section, set linearity to 4 and gain to 0.2. And I will have a noise texture that looks like this. In the script, let me pass the noise texture as sampler 2D to our compute shader. I've already shown it in the previous video by passing the depth texture, so I will go over this stuff little quickly. So in the render callback method, I need to create a uniform object like this. Now I don't really want to write the same thing twice, so let's copy this, create a new method, function get uniform, and it will return RD uniform. And paste the code here. Then I will pass the RID, uniform type, and binding from the calling code. So let's create parameters. RIDs of type array of RID, because I might need to add multiple RIDs. Then type of type rendering device dot uniform type, and finally binding of type integer with the default value of 0. So if I don't pass binding value, it will take 0 as default. Then in the binding, pass the binding, uniform type equals type. Then let's iterate over the RIDs array for RID of type RID in RIDs. Then instead of the screen texture, let's pass the current RID. Finally, return our uniform. Then in the render callback method, I will call my new method. So uniform equals get uniform then pass array with screen texture, and the type will be rendering device dot image. Then I will delete this. Now to pass the noise texture as sampler 2D, I need to create a sampler first. Let's quickly create a linear sampler. Let me declare it first. Var linear sampler of type RID. And you need to free this sampler once you are done to avoid memory leaks. So in the notification method, let's free it. First, let me split this condition. Then let's check if linear sampler is valid. If so, let's free it. Then in the initialize compute shader, let's create our sampler, and I've shown it in the previous episode, so I will just type it. Then in the render callback method, let's get a new uniform. So uniform equals get uniform, and pass array with linear sampler first, then our noise texture, and the type will be sampler with texture. Pretty easy, right? But there is one little catch here. My noise texture is not of type RID. It is a texture 2D. So I can't pass it like this. I need to convert it. So var noise image of type image equals noise texture dot get image. I have the image reference noise image dot convert format rf. I've converted the image format with 32-bit float precision in R channel because the noise is just a grayscale texture. Now I need to create a texture format reference. Var texture format of type rd texture format equals rd texture format dot new. Then let's set the texture width. Texture format dot width equals noise image dot get width. Then set the height. Then let's set the image format, and I have to match it with this format. Then I also need to set the usage bit, usage sampling bit. With this line, I'm simply telling that this texture can be sampled. And finally, with this texture format reference, I can create an RID type. So let's first declare it, var texture of type RID. Then I also need to free it when I'm done. So in notification method, check if texture is valid. If so, let's free it. Then back in the render callback method, let's create a texture RID. Texture equals rd dot texture create with my texture format. Then I need to pass the view instance, so simply rd texture view dot new, and I need to pass the byte array, so noise image dot get data. Then I can pass this texture in the uniform. Then let's create a uniform set, var noise texture set of type RID equals uniform set cache RID dot get cache, and pass shader. Then the set ID, I need to match it with GLSL file, so 1, and then pass array with uniform. Then let's bind this uniform set with the pipeline, so just duplicate this, then pass noise texture set, and once again I need to match this set ID with my GLSL file, so 1. Now let's test it. So simply reload this scene, And I have noise texture. Now in the script, let me create a progress variable, export range from 0 to 1, var progress of type float equals 0. And the export range annotation will give me a slider in the inspector that goes from 0 to 1. Then I want to pass it to my compute shader as push constant. So in the render callback method, instead of the 0, I will pass progress. In the GLSL file, let's sketch the progress. So in push constants block, float progress. Then in the main function, let me create a mask. So float mask equals step of p.progress and noise. And step function will return 1 if the progress is greater than the noise value, otherwise returns 0. Then let's visualize the mask instead. Let's reload the scene. And I have a full white screen. Now if I tweak the progress, you can see where this is going, right? Alright, now instead of this white parts, I want to see the scene color. So I will simply go color.rgb multiply equals mask. Let's reload the scene. And now I have scene color. Awesome. Now I want to create an edge around the black parts. For that, I will just duplicate the mask, call it edge. Then I will subtract some smaller value from the progress. So here I will just get a slightly bigger mask. Then I will go edge minus equals mask. So I will only have edges or borders. Let's add it on top of the color. So color.rgb plus equals edge. Let's test. And I have borders. Now I want to color them and make them glow. In the push constant block, let's grab intensity and color. Then here, let's go edge multiply p.color multiply p.intensity. In the script, let's quickly create variables for color and intensity. Then let's pass them as push constants. So push constants.append intensity, then append color.r, g, and b. And you need to pass the push constants as pair of 4. So this is one pair, and here I will go push constants.append 0. Let's test, and I have colored edges. Let's adjust the effect a bit. Alright, the effect looks a bit nice. Now I want to update this progress value on scene change. For that, I will create an autoload. An autoload is a singleton that will exist in all scenes. We can use it to share and pass information between various scenes. But I cannot make this world environment node as an autoload. Why? Well, this scene has some environment settings which is exclusive to this scene. In scene B, I have some other environment settings, so I need to preserve that. One easy method is to duplicate this world environment node. I will call it scene transition. Then I will remove this environment resource. Similarly, in world environment node, I will remove the compositor. And now I can make the scene transition node as an autoload. For that, right click it, save branch as scene, save it at your desired path. Then I can safely delete it from my scene. Then in the project settings, go to Globals tab, then Autoload. Here browse for our scene transition scene. Then you can give a name which can be used to access the autoload. I will keep it scene transition and hit the add button. And now if I run my game, you can see that the scene transition node will always exist, even when I change the scenes. Cool! Now is the time to animate our progress. For that, let's create a script. I will call it scene transition. Open our scene transition scene and attach our script to our scene transition node. In the script, I will give a class name autoload scene transition, which extends from world environment. Then to update the progress over time, I will create a tween var transition tween of type tween. Tween is a class used to update a value or property over time. Then I will declare one more variable, export var transition duration of type float equals 1 to specify my animation duration. Then I will create a new method, function create new tween, which will have two parameters, start value of type float and end value of type float, and it will return nothing, so void. Here I will initialize my tween, so transition tween equals create tween, then set the ease type transition tween dot set ease and ease in, just an interpolation type. Then I will go transition tween dot tween method, then the method will be update progress from start value to end value, and the duration will be transition duration. So this will call the update progress method and will pass a value as a parameter that goes from start value to end value over this amount of seconds. And update progress method does not exist, so let's create it. Function update progress. It will take a float as a parameter, so progress of type float, and it will return nothing, so void. Here I will access the compositor. It has compositor effects array. Let's access the first element because that's where I have applied the transition effect. Then simply go progress equals progress. Then here let's also set a transition type, so set transition of type quad. Then let's call this method in ready method, create new tween from 1 to 0. And now if I run my A scene, I will have this animated effect, but then nothing will happen on the scene change. Let's fix that. In the autoload script, let's create a new method to change the scene. Function change scene, and it will take a scene name as parameter, so target scene of type string, and it will return nothing, so void. Here first let's check if transition tween, if it is not null, then transition tween dot kill, so it will abort any current running tween. Then I will go create new tween from 0 to 1, animate progress to go from 0 to 1, then await transition tween dot finished. This line means wait until the tween emits the finished signal. Then I will change the scene, so get tree dot change scene to file, then pass the target scene. Then once again call the tween, but this time from 1 to 0. Create new tween 1 0. Then in my scene switcher script, where I'm changing the scene, instead of this, I will simply call my autoload method scene transition dot change scene. Let's test it. And I have this nice scene transition effect. Pretty cool. Now before you click off, I have some exercises for you. Instead of replicating the same effect, try to create a circle swipe effect or a classic circle transition effect, or you can create some exotic effect like the swirl. Okay, I admit swirl effect will be a bit hard, but it is achievable by being a bit creative. And on this channel, I've covered the required techniques, So I'm confident that you can do this. And that's all I have for you today. If you're interested in the compositor, I've explained it from the scratch in this video. Check it out and I will see you there.